So this is module 2, switching concept. In this module, we have two topics, frame forwarding and also switching domain. So frame forwarding. So switching in networking. Two terms are associated with frames entering or leaving an interface. Ingress for entering the interface. Ingress exiting the interface. A switch, forwards based on the ingress interface and destination MAC address. A switch use its MAC address table to make forwarding decision, according to this port table. All right, so these are destination address, and also this is the port. Note, a switch will never allow traffic to be forwarded out the interface it received the traffic. The switch MAC address table. So a switch will use the destination MAC address to determine the egress interface. Before a switch can make this decision, it must learn what interface the destination is located. Switch build a MAC address table, also known as a content addressable memory, CAM table, by recording the source MAC address into the table along with the port it was received. The switch learn and forward method. The switch use a two-step process. Step 1, learn. So examine source address. So it will adds the source MAC add the source MAC if not in table. After that, reset the timeout setting back to 5 minutes if source is in the table. Step 2, forward, or it will examine destination address. Let's say if the destination MAC is in the MAC address, so it is forwarded out the specified port. And let's say if a destination MAC address is not in the table, it is flooded out all interfaces except the one it was received. So this is a video that shows MAC address table on the connected switch. So you can play this in our NetAcad. Yeah. All right. Next. Switching forwarding methods. Switches use a software on application-specific integrated circuits, or ASICs, to make very quick decision. A switch will use one of two methods to make forwarding decision after it receives a frame. First, store and forward switching. Receive the entire frame and ensure the frame is valid. Store and forward switching is a Cisco preferred switching method. And cut-through switching. So for cut-through switching, forward the frame immediately after determining the destination MAC address of an incoming frame and the ingress port. Store and forward switching. Store and forward has two primary characteristics. First, error checking. Second is buffering. For error checking, the switch will check the frame check sequence FSC for CFC errors, and bad frames will be discarded. For the buffering, the ingress interface will buffer the frame while it checks the FCS. This will also allow the switch to adjust to a potential difference in speed between ingress or egress ports. Cut-through switching. So cut-through forwards the frame immediately after determining the destination MAC. Fragment. Fragment-free method will check the destination and ensure that the frame is at least 64 bytes. This will eliminate runs. Concept of cut-through switching. So is appropriate for switches needing latency to be 10 microseconds. Next, does not check the FCS, so it can propagate errors. Next, may lead to bandwidth bandwidth issues if the switch propagate too many errors. And next, cannot support ports with differing speeds going from ingress to egress. So this is the concept of cut-through switching. Next, 2.2 switching domain. So collision domain. So switches eliminate collision domains and reduce congestions. When there is full duplex on the link, the collision domain are eliminated. When there is one or more devices in half duplex, there will now be a collision domain. There will now be contention for the bandwidth, and collision are now possible. So most devices, including Cisco and Microsoft, use auto negotiation as the default setting for duplex and also speed. All right, so this is diagram. So broadcast domain. So broadcast domain extends across all layer 1 or layer 2 devices on a LAN. Only a layer 3 device router will break the broadcast domain, also called a MAC broadcast domain. The broadcast domain consists of all devices on the LAN that receive the broadcast traffic. When the layer 2 switch receives the broadcast, it will flood it out all interfaces except for the ingress interface. Too many broadcasts may cause congestion and poor network performance. Finally, increasing devices at layer 2 or layer 1 or layer 2 will cause the broadcast domain to expand. Alleviated network congestion. Switches use the MAC address table and full duplex to eliminate collision and also avoid congestion. Features of the switch that alleviate congestion are as follows. First, for the protocol pass fault speed. So we got, depending on the model, switches may have up to 100 gigabit per second port speed. And we have a for the protocol like fast internet switching. So it will provide the function. So this use a fast internal bus or share memory to improve performance. And for the large framework buffers, this allow for temporary storage while processing large quantities of frame. And for the high-speed density protocol, this provide many ports for devices to be connected to LAN with less cost. This also provide for more local traffic with less congestion. All right, so here is the module practice and quiz, and you can go through all this. All right, that's all for chapter